Okay. We are going, probably, some of you will rattle through a lot of this. This first question, I think all of these we can do factorising and in vertex form. So it asks you to do it in completing the square. Right, so that's one thing to sort of note. Completing the square, that ends up in vertex form, right? We've made that link because the doing the minus or plus bit at the end is the completing the square bit. And we talked about how we can solve them. You'll notice all of these, you've got a quadratic expression equals 0. So all these are quite nice. We've still got equals 0. All of these are equals 0 until you get to the ones down here, which are obviously a lot more complex because you have to do some rearranging first. But I'll just focus on this question 1 first. We'll go through it. Well, let's go through a couple of examples. Yeah, okay. So we'll do x squared plus 6x plus 8 equals x. So solve x squared plus 6x plus 8 equals 0. And we're going to do it, and you're going to do it just for practice, right? We're going to do it in factorised form way, and we're going to do it in vertex. And you should end up with the same answers both times. If you don't, something's gone wrong. Right, let's do in factorised form first. So factorising by factor. Would anyone like to offer house tools? Okay.
Well, 4 times 2 equals 8.
Yeah.
And then 4 plus 2 equals 6. So it's x plus 4 and then x plus 2.
Good stuff.
Equals 0.
Equals 0. Next step, you know it? So you factorised it, we just need to now do the solving. Snap them? Yeah. So x plus 4 has to equal 0, or x plus 2 has to equal 0. So in this case, x has to be -4. In this case, x has to be -2. So remember what we said yesterday. It's not just take the number and do the opposite, because that kind of works with the simple ones. That would be the criterion B skills kicking in amongst you. It's like, oh, but this is what always seems to happen. We always just take the opposite. But with the criterion B, it's important that you then expand it to different ones to see if it still works, rather than just apply that. Okay. Okay with that? Nice and simple one. The factorisation bit is kind of the hardest bit of that stage. The solving bit at the end as well. Let's do it by completing B, by completing the square. Okay. So what do we do first then? Yeah. Do vertex form. Anyone want to talk me through it in vertex? I rewrite x. 6. So what do we do first step in vertex form? So what do we end up with? A set of brackets, and it's x plus 3 square. Okay? Good. We've got to complete that bit, so I haven't given myself too much space, but x plus 3 squared would give me x squared plus 6x plus 9, but I want plus 8, so I need to minus 1. Okay, so I've completed the square. Now I need to solve that. So now I'm at the solving stage. What do we do? Add 1 to both sides. Good. That gives me x plus 3 squared equals 1.
And you take the square root.
Take the square root. So if I square root that side, I get left with just the x plus 3. And if I square root that side, because it's a nice, simple, easy one, what's the square root of 1? 1. Then we minus 3. So if we minus 3, we get x equals negative 2. Right. Do we have the same answer as previous? Hey? Yeah? Completely? No. No. What's missing? The negative 4. Where does that come from?
Wasn't it like 2 possibilities?
Oh yeah, we know what they are. It's minus 4 and minus 2. We've got factorised form at this moment. Looks like it gives us both answers, and vertex form looks like it only gives us 1. We're missing something. Where does the second answer come from? Okay. Look, if you think about it, we've got to vertex form. There's no longer an 8 there. This is vertex form. Right? We kind of, at that stage, we stop and we deal with this form here, don't we? Like in vertex form, all right, we don't use standard form anymore, we use vertex form. So, there should be a second answer. We know what it is, it's negative 4. We need to get it. We did talk about this yesterday. It's an important aspect.
With negatives, give it to x.
Well, what would that give me? 0. Yeah, that's what. That would show negative 2 as a correct solution, but it doesn't give me the other one. Come on, guys. Faith in you. What are you missing that we talked about yesterday?
Substitute.
I'll pause, making for. At this bit, look, we said the square root of 1 is 1, but it's also negative 1, like Connor said. At this stage, here, look, this is the important bit, the square rooting bit, we also have a second option, which is x plus 3 is equal to negative 1. The square root, we should always have a plus and minus square root. I remember Jackson telling us yesterday. Not paying attention. So, so we do have the 2 options. We have the plus 1 option that we dealt with. Now we have the negative 1. What happens? We have to do exactly the same. We subtract the 3, and we end up with x equals, so 4 negative. There are my 2 solutions. So that is this bit here, isn't it? That's the important bit. So square roots have positive and negative. Okay. That's where your 2 solutions come from in this sense. So in factorised form, it's because we have 2 brackets. Vertex form, just because of the square root. What will happen, by the way, anyone twigging on it, what will happen in vertex form? Actually, let's go through. I'm going to give you one more. It might not be on the sheets, but I'm going to see whether you can do it, which is, I'm going to get you to solve x squared plus 8x plus 16 equals 0. And I want you to do it in both ways, please. And see if you spot it. Just like we just did, yeah. Both ways. So factorise form and then vertex form. This one, anyone recognise it? What it is? It's an example of a perfect square. So I want you to have a look at perfect square because it suggests something. Let's just talk it through. I think you've got to the bit that what I wanted you to get to. So perfect square, you don't have to be at this stage, but it'd be very good for you, efficiency-wise, to go, oh, perfect square, therefore I know this is x plus 4 times x plus 4. Or x plus 4 squared. And then you might go, finding, yeah. Focus, yeah. Or you'll notice that actually writing a perfect square in that way is just vertex form. But there's no plus or minus bit, right? Because it's already there. So perfect squares are nice like that. So we actually end up with the same thing. And in this case, if we look at it like this, what are the solutions? Well, we only have to solve x plus 4 equals 0. Well, what do we have to do here? We have to do x plus 4 equals the square root of 0. Plus and minus, of course. But what is the square root of 0?
0.
0. Plus 0 and minus 0. But that's just 0. You see how we end up exactly the same thing? So what are your solutions? X equals negative 4. How many solutions are there? Just the one. What would the graph look like? Huh? So if we were to graph this, it would touch the x-axis where? Where? Negative 4, yeah. Do this, that would be at negative 4. Where would it cross the y-axis?
Yeah, well,
16. Yeah? From this form. Right? What would its vertex be? Negative 4, 0. That negative 4 plus 0 would make that. So just want to show you that one because perfect squares, I don't want you to think, oh, well, I've only got one answer, therefore I must be wrong. But that one answer will always come from the square root of 0 because plus 0 and minus 0 is the same thing. We did have, so just think about it, bringing things together a little bit. What would the graph of this one look like? Yeah, so it would cross at negative 4, it would also cross at negative 2.
and y is 8.
8, yeah, yeah, 8. So this one would go down, okay, what's the coordinates of the vertex? Negative 3, negative 1, yeah? Negative 3, oh no, sorry, wrong one. Negative 3, negative 1, right? It's all making sense, right? That gives me 2 solutions, this gives me the ones. What's the third thing we have to be aware of? The no solutions. So although we're not going to quite go into it in depth now, can anyone just think, well, obviously the no solutions thing is going to happen. What do you think will happen if I try and factorize one with no solution? It won't factorize. Now just a note, not all of them that don't factorize won't solve, right? Some of them won't factorize. We did one yesterday, remember it turned into decimals and stuff? Yeah, you had one on your test, didn't you? The last question on your test was use the computer calculator to find the 2 points, and they were like negative 5.854 or something, and so yeah, that one wouldn't factorize. That's why we've got the decimal. We would, however, be able to use vertex form to solve that one. So No solutions would mean it wouldn't factorise. It will work in vertex form, but what do you think would happen in vertex form if you tried to solve one that was not solvable? Decimals are fine, actually. Okay. I'm going to just ask you to maybe think of that while you're doing the others. At the end of the lesson, I'm going to give you a vertex form one that won't have any solutions. I'll see whether you know. But let me know quietly if you've thought about it now. But one that won't factorise, won't have any solutions, maybe. And vertex form. There is something about vertex form that you can see, oh, this one won't have solutions. All right, but over to you now. Practice-wise, you've got that sheet that I've just been working on. We've just done that one. You may well find some perfect square ones amongst there, okay? You should be able to do both forms for question one. Check with me if you don't think it does work in both ways. All good? Bit of practice? Yeah? Okay, go for it. I am going to just show you, because this is a good time to do it, using your calculator. So the power of your TI Inspire. Now, unfortunately, once I've shown you this, probably your next assessment is going to be non-calculator, because it will be too easy. All right? But it does lead you to be able to sit at home and go, oh, all the answers that Mr. Potts is going to ask me for in homework can be found checked using the calculator. So, have you got your TI Inspire in front of you? Yeah? Okay, what you are going to do on your TI Inspire, I'm going to go to a calculate page. Alright, so I've already that. Alright, and you're hopefully, if you've got a good understanding of everything we've been doing up to this stage, you'll be like, the next menus I show you, you're going to be like, oh my god, that's everything I need to do. So, go to menu, go down to algebra. Okay. Have you got more than me?
No, I've got the same with 3.
Okay. So I just did that. Okay, so this will be on the video now. So we solved vertex form. We end up with those two solutions, but I'm telling you it won't work. I would like you to think about why. My tip is just try and convert those into decimals and tell me what happens. Okay, have a good day.